All right, so let's work out some more examples from the unit circle. So example 2, we want to find sine, cosine, and tangent of 0 degrees and pi over 2. So 0 degrees, of course, would be not really any angle at all. It would just be this line straight out on the x-axis. Well, if the radius, we're talking about the unit circle, the radius is always 1, think about what the coordinates for this point would be right here. The x-coordinate would be 1, the y-coordinate would be 0. And of course, why that is important, because sine, we just learned, is equivalent to the y variable. So the sine of 0 degrees should be 0. Cosine is equivalent to the x variable, so the cosine of 0 degrees should be 1. And the tangent at 0 degrees is y divided by x. And in this case, it's 0 divided by 1. 0 divided by 1 is 0. So a lot of times these special angles at 0, 90, 180, and 270 are slightly easier. And that brings us to example 2. Example 2 is pi over 2, which we know, of course, is equivalent to 90 degrees. So we're talking about right here, straight up 1 unit from the origin. So that means we know the coordinates for this point are x is 0 and y is 1. Basically, we go through the same process. Sine is equivalent to the y-coordinate. So that means the sine of pi over 2 is 1. Cosine is the x variable, so it's going to be 0. And tangent is y over x. You can't divide anything by 0, so the tangent at pi over 2, our answer is undefined. So example 3, we're doing the same thing, but now we don't have the special angle of 0, 90, 180, or 270. Example 3a, we're looking at 240 degrees. So let's start by sketching 240, and you need to find the reference angle at 240 degrees. So 240 is going to be 90 plus 180 plus about 60 more. So 90 plus 90 plus 180 gives us 60. So 60 would be our reference angle in this problem, because it's formed at the x-axis and that angle is acute. So our reference triangle is this right here. See if you can go ahead and find the y-coordinate and see if you can find the x-coordinate. So the x-coordinate should be 1/2, or actually -1/2. And it's -1/2 because think about what quadrant we're in. We're in quadrant number 3. And in quadrant number 3, both the x and the y coordinate are negative in quadrant 3. Which means the y coordinate is also going to be a negative, in this case, negative radical 3 over 2. So you have to add that one additional factor in to the special right triangles, thinking about what quadrant each one of these angles is going to be in. So now we've done the hard part. Sine is the y coordinate, so it's negative radical 3 over 2. Cosine is the x-coordinate, so it's -1/2. And tangent is y over x. So this one we have to show a little bit of work for. So a negative divided by a negative, keep in mind this answer should be a positive. 2's cancel, the negatives cancel. We end up with positive radical 3 for the tangent of 240. Go ahead and see if you can sketch 5 pi over 4. If it's helpful, write pi over 2, 1 pi, 3 pi over 2 here. So 5 over 4 is 1 1/4. So that means we're talking about this quadrant right here, which means our reference angle is going to be whatever this angle right here is. And to get that, we can just take 1 pi and subtract it from 5/4. In other words, 5/4 minus 5 over 5. Nope, not 5 over 5. How about 4 over 4? We need a common denominator. So that means our reference angle is pi over 4. At this point, you really can convert these to degrees if it's easier. The radians aren't going to affect any of this work. So you could have converted 5 pi over 4 to degrees right off the bat. This is the same thing as 225 degrees, which means this is a 45, 45, 90 degree triangle. Hypotenuse is 1. And again, think about what the sign should be in this quadrant. We're again in the third quadrant, so they're both negative. Hopefully this is one you've almost memorized at this point. X and Y should both be negative radical 2 over 2. You start seeing some patterns to develop, and it doesn't take you as long to do some of these problems. Tangent is the y coordinate divided by the x. And since it's a negative divided by the same negative, the tangent of 5 pi over 4, or the tangent of 225 degrees, should be positive 1. I would encourage you to try this last one on your own, negative 300 degrees. Keep in mind, negative 300, I'll help you with the sketching part. We have to go the opposite direction. So this is negative 90, negative 180, negative 270, plus an extra negative 30 degrees, which means our reference angle for this problem, the shortest distance to the x-axis, is 60. Or in other words, really what we're doing is we're finding the sine of the angle that's coterminal to negative 300. So really we're finding the sine, cosine, and tangent of 60 degrees. And this is where knowing your coterminal angles makes this a lot easier. So I encourage you, pause the video and see if you can do the rest of this problem on your own. So again, this is the hard part, is filling in using your special right triangles. Now, to find the sine of negative 300, all you have to do is look at the y coordinate, which is radical 3 over 2. For cosine, it's the x coordinate, which is positive 1/2. And notice everything's positive since we're in the first quadrant. And tangent is y over x. So it's radical 3 over 2 divided by 1/2. Flip and multiply, the 2's cancel. You end up with a radical 3 at the top of the fraction, which is okay.